Today we're talking about perform functions, operations, and compositions. So we've already talked a little bit about f of x and g of x. And today, instead of having, numbers, you could have multiple things. So notice here, this is what f of x represents, and this is what g of x represents. So on example 1, they want us to simplify. So we're plugging in our g of x and f of x. So since g of x is 5x to the 1/3 plus 4x to the 1/2, we're going to go ahead and write that. And then we're going to add f of x to it. So we're adding, and then f of x is right here. So we have a negative 3x to the 1/3 plus 4x to the 1/2 power. So we're going to combine our like terms. So if you look through here, our like terms, we have a 5x to the 1/3 and a negative 3x to the 1/3. We can add those together because these basically are like roots. They both have 3 in the denominators. So we're keeping, this really represents the cubed root of x. So we can add these two together, which will end up making 2x to the 1/3 power. And then same thing here, we have a 4x to the 1/2 and another 4x to the 1/2. So we can add those together, and that makes 8x to the 1/2 power. So we've simplified it, and then they also want us to state the domain. So when you were talking about the domain, remember that domain is your x values. So we have to think about what is going to make the x values real numbers, meaning that they cannot be imaginary numbers. So if you're plugging in x here, and this is a cubed root, it really could be positive or negative numbers. But for an even root, it can't be negative numbers because that will give us an I, an imaginary number. So for this problem, because we have an even root, it can only be, our domain can only be all non-negative real numbers. Now the reason why I wrote it like that, all non-negative real numbers, is because that's how you will see it on your test and in the book. But if you also wrote just like all positive numbers, both positive numbers and 0, because all non-negative real numbers, that includes 0. So all positive numbers and zeros, that also works. That means the same thing. So this whole thing is our answer. So that's the problem simplified, and this is our domain, all non-negative real numbers, which means all positive numbers and 0. Okay, let's move on to example 2. So this one we were adding them. On this we are subtracting them. So again, we're going to take our value for g of x, which is 5x to the 1/3 power plus 4x to the 1/2 power. And then we're subtracting f of x. So we're subtracting the whole thing that f of x is. So now I have to write this in parentheses because we're going to end up distributing the negative through. So I have negative 3x to the 1/3 power plus 4x to the 1/2 power. We go ahead and distribute the negative through there. And when I do that, this negative becomes a positive, and this positive becomes a negative. And then this changes to a plus sign. So again, now we're going to combine our like terms. This time I have a 5x to the 1/3 and a positive 3x to the 1/3, which makes 8x to the 1/3. And then we have 4x to the 1/2 and a negative 4x to the 1/2 power. So those end up canceling out. Okay, so now my answer here is 8x to the 1/3 power. So that's my answer simplified, and then I need to state the domain. Well, so this, what values could x be? Well, since I have a cubed root, I can have both positive and negative numbers. So that means on this one, my domain is just all reals. And that's it. That's your answer. So again, this one, because it's a cubed root, we can have positives and negatives. If this had been an even root, like 2, then it would have to be the all non-negative real numbers. All right, moving on to example 3. My printer didn't print this out correctly, but this should have been f of x. This is supposed to be times. So instead of that box there, it should be times. F of x times f of x. And now we have different values for f of x and g of x. So notice now f of x here is 4x to the 2/3 and g of x is 5x to the 1/2 power. So again, we're going to simplify and state the domain. So for f of x, that means I'm writing 4x to the 2/3 power times 4x to the 2/3 power. When you are doing this, when you are multiplying, numbers and numbers multiply. So 4 times 4 is 16. Now when you're dealing with exponents, when you're multiplying, what do you end up doing? The correct answer should be adding. And for example, if I had, let's just say here to the side, if I had 2x times 2x, and I multiplied that together, that would equal 4x squared, because I multiplied the 2 times the 2, and then x and x makes x squared. So that's the same thing we're doing here, except for this one, instead of being x to the 1st power like it was here, this is x to the 2/3. So we were adding 2/3 plus 2/3, which makes 4/3. We already have the common denominator, so we add the tops together, and we keep the denominator the same. So my answer is 16, and then it's x to the 4/3 power. So now we've simplified, and we need to state our domain. So what do you think our domain is going to be? You have to look at what your root number is, and my root number is 3. So if the root number is 3, can I only have non-negative real numbers, or can I have all numbers? Good, and the answer is all real numbers, because you can have positives and negatives with the cubed root. And there's your answer. Okay, example 4. So now we have g of x divided by f of x. So our g of x is 5x to the 1/2 power, divided by our f of x is 4x to the 2/3 power. So my issue here is what? Hopefully you said that I can't have a 2/3 in my denominator, because that really represents a cubed root. Okay, so there are a couple ways of doing this, but for these answers, they're going to be, I'm going to teach you the way that they are written as answers. So I can't have 2/3 in the denominator. I want to end up making this a 3/3, because if I had 3/3, that would reduce to 1, which means I would just have an x in the denominator. So in order to get rid of that 2/3 and make it a 3/3, we need to multiply by x to the 1/3 power. Because again, remember that we are adding exponents. And just to show you real quick, this really represents the cubed root of x squared, or x times x, right? And this really represents the cubed root of x to the 1st, or just x. So if you notice, that ends up making our group of 3, which will just give us an x. So instead of writing all this out, I can just keep it as exponents, and I just want to make it 3/3, which will then end up reducing to be 1, which is just x. But whatever I do to the bottom, I also have to do to the top. So here on the bottom, we end up getting 4 and then x to the 3/3, because we're adding, and we keep the denominator the same, 3/3, and that 3/3 ends up reducing, and we just end up with 4x in the denominator. Now on the top, I have 5x, and I need to add 1/2 plus 1/3. But in order to add those together, we have to get common denominators. So what would be my common denominator with 1/2 and 1/3? 6 is correct. So 6 is in the denominator, and then what 2 times 3 makes 6, so 1 times 3 is 3, and over here 3 times 2 makes 6, so 1 times 2 is 2, and we add that together, and 3 plus 2 equals 5/6. So my numerator now, the top, is going to be 5x to the 5/6 power. And that is my answer. And I can't reduce this because this really represents the 6th root of x to the 5th. So this is like in a root, and this is not in a root. So I cannot reduce them. And then what else do I need to state? My domain. Okay, so my domain on this. If you look at what would represent my root, I have a 6 as a root. So when you have an even number, can we have negatives inside? No. So that means my domain is all non-negative real numbers. And those are my answers. Okay, moving on. So we have some compositions, okay? And what it states here is to state with the innermost parentheses and work your way out. So if you look here at innermost parentheses, we have f of 3. So this is where you start first. You are going to find the answer for f of 3. Whatever is in the inside part, you start there and work your way out. So f of 3, that means I'm going to my f of x equation, and I'm plugging in 3 for x. So f of x is 3x plus 2. So we have 3x plus 2, but instead of writing x, I'm now going to write 3. So I have 3 times 3 plus 2. 3 times 3 is 9, and 9 plus 2 is 11. So we know that f of 3 is actually 11. So what we're doing is I'm now going to cross out f of 3. I'm going to write g of 11 because I know that f of 3 is 11 because I worked this out. So now we are going to find what is g of 11. So I go over to my g equation, which is right here, and my g equation is negative x squared. Now notice please, is the negative being squared or is the x being squared? Hopefully you stated that just the x is being squared. The negative is just out there in front. It's almost like saying negative 1 times x squared, and we do the x squared first and then it becomes negative. So that means I have negative and then I have 11 squared. And what is 11 squared? 121. So my answer is negative 121. And that is the answer to the problem. So these are 2 set problems for these. All right, so let's try the next one. We have g of 4 is my innermost parenthesis. So I'm going to circle that because I have to do that first. So we go to our g equation, and my g equation is negative x squared. We're plugging 4 in for x, so that means I have negative 4 squared, and then I end up with negative 16. So now we know that g of 4 actually represents negative 16. So that goes away, and I'm going to rewrite this as h of negative 16. So my new problem now, this is h of negative 16. So I go to my h equation, which is x minus 2 over 5. So write that out. I have x minus 2 over 5 is my h equation, and I'm going to plug in negative 16 for x. So that means that I have negative 16 minus 2 all over 5. And negative 16 minus 2 is negative 18 over 5. And can that reduce? No. So that is my answer. All right. So we're going to move on to some more problems. The difference between the problems I just did and these problems is that if you notice, you're keeping an x in the problem, where on my previous examples, instead of there being an x, we actually distributed or substituted in a number for the equations. Here, we are keeping an x. We're substituting an x in. Also, if you notice, on your homework, problems 30 and 33, they have different f of x and g of x's. I want you to not do what it states in the book, but use the f of x and g of x and h of x that I have written here. Okay, so example 7. We start with our innermost parentheses. So hopefully you see the innermost parentheses here are g of x. So we go to our g of x equation, and g of x equals 2x minus 7. And if we were substituting x in for 2x minus 7, or for the x in here, it's not changing anything. So my answer for g of x is just 2x minus 7. So that means I cross out my g of x, because now I know that g of x actually is 2x minus 7. So now I'm finding h of 2x minus 7. So I go to my h equation, which is over here, x plus 4 over 3. So my h equation is x plus 4 over 3, but we're going to change that because I'm taking 2x minus 7 and I'm plugging it in for x into this problem. So that means instead of writing x, instead of writing that part, I'm writing 2x minus 7. So we have 2x minus 7 plus 4 divided by 3. And we simplify. So when we simplify here, I get 2x, and negative 7 plus 4 is negative 3 all over 3. And that can't reduce. So this is just going to be my answer. It also states to state your domain. So on this one, my domain, if you look at exponents and roots, I don't have any roots in here. So could I have could a negative number be plugged in for x and it still give you a true statement, no i's? Yes. So on this one, my domain is my all reals. Okay. Let's try example 8. So again, on example 8, we go to our innermost parentheses, which is g of x. So I go to my g of x equation, which is 2x minus 7, and I write that down. So we have 2x minus 7. So if we were substituting x in right here, it doesn't change. It stays an x. So g of x, this goes away because I know that g of x is 2x minus 7. So now I'm writing my new equation. It's going to be g of 2x minus 7, because I'm taking this and plugging it in right here. So again, my g of x equation, because now it's saying g of 2x minus 7, but my g equation is 2x minus 7. So this time, I'm plugging in 2x minus 7 for x. This previous time, I plugged in x for x, but now I'm plugging in 2x minus 7 for x. So when I rewrite this, it is going to be 2 times, and instead of writing x, we're writing 2x minus 7, and then I still have a minus 7 at the end. So we simplify. 2 times 2x is 4x, and 2 times negative 7 is negative 14, and then we still have minus 7. And we simplify further, and we get 4x minus 21 as our answer simplified. And then we also need to state our domain. So on this one again, think about, are there any even roots in that problem where we couldn't have a negative number? And there isn't. So again, this domain is all reals. Okay, so last example, we have now f of x. So we go up to our f of x equation, and our f of x equation is 3x squared. So my f of x equation, my f of x is 3x squared. So that means instead of writing f of x now, we now have 3x squared. So my new problem, because I'm taking this and plugging it in for that f of x, is now f of 3x squared. So again, we know that our f equation is 3x squared. So now this x right here, that I am now plugging in 3x squared for that x. That's what we're substituting in now. Please pay attention that the only thing that's being squared is the x, not the 3 here, okay? So that 3 right there is kind of separate. So when we write this, we have 3, and then I'm going to make a parenthesis because my f of x is 3x squared, close my parenthesis, and it's squared. So the x is now 3x squared. So now the parentheses is what's being squared here. So we go through here, and I still have this 3 that's on the outside, and then when I square that 3, it becomes 9, and when you square x squared, it becomes x to the 4th. And then now we can multiply 3 times 9, which is 27, x to the 4th. And then our domain. Do we have any even roots that we need to worry about? And if you go here, like if you plugged in a negative number, you would still get your answer doesn't have to be positive, but we'd end up with a positive because you're taking something to the 4th power. But it doesn't, you can use all real numbers here because we don't have a root that has an even exponent and would give us an I. So that's my answer.